guys, I think we're going to get started. We'll wait maybe for a couple more people to filter in. But my name is Mike. I'm one of the founders of RethinkDB. And RethinkDB is an open source database. It's been around for maybe we've been building it for 5 years. It's been out in the world for maybe 2. And it's a big project on GitHub. We know and love GitHub. It's actually the second most starred NoSQL database on GitHub after Redis. If you guys want to participate in a great open source project, or you want to just suggest features or anything else that's exciting to you, you should come check out the GitHub repo. We also have couple t-shirts left. I came with a giant suitcase. This is like all that's left. So if you want to grab some stickers and things later on, you're welcome to do so. I'm also going to stick around a little bit after the talk if you have any more questions for me. So what I'm going to talk to you today about is real-time apps. And RethinkDB, as I said, it's really built for the real-time web. It's a really full-featured functional database, but we built it specifically to solve a particular class of problems. And the first question is, what do I mean by a real-time app? So we're all familiar. I think everyone remembers probably their first experience when they opened like Google Docs, and you're like, oh, it's a text editor. And then magically, you started seeing people typing. You're like, oh my God, this isn't just a text editor. And you're like, this is really cool. Like I'm actually interacting with people in real time. And suddenly, like this app felt alive. This is something that like feels very potent, very visceral. Another app that we know and love, especially at RethinkDB, is Slack. Slack is like a chat app. I don't know how many people here use Slack? Raise your hands. Yeah, there we go. So Slack is like amazing because it's not just chat. Like people done chat like 50 times before, but it's chat that lives like in the browser, as an app on your desktop, on the phone, and it doesn't matter where you are. You just sort of open it up and you start like Slacking people. In fact, I love Slack so much. I get an email every week that says, who uses it, what the statistics are, and I usually hold the record for most emojis. So I love Slack, it's amazing. And this kind of thing, this is the kind of app that basically people want to build. If you have like any kind of app you're building, it's one thing to be a static app that sort of queries, occasionally updates itself whenever you reload the page. But if you build this kind of experience, people love it. They get engaged in a way that's really exciting. The problem is, building these apps is like really, really hard. The biggest problem is it's really hard to keep track of state when you're building a real-time architecture. So I'm going to show you a couple architecture diagrams, for which I apologize. I usually hate them. The problem is it's really hard to talk about these kinds of things if we don't figure out how they're built. So this is how most people build real-time apps. If you have your database, which is basically your like source of truth. It's where you're storing a bunch of data within your cluster about your users. Let's take Slack. You have a bunch of messages that you want to store and persist somewhere. On top of it, you have a bunch of different app servers. You have your Node app that's running the web client. You have your app that's running the desktop client. And then maybe you have a different app a different server that's running your mobile apps. And the reason why is you want something different on mobile than you do one on the desktop. For example, geolocation, things like that. So you have different requirements, different needs. And maybe you want to put a dashboard on top for reporting. So you have another different server that's sort of trying to figure out what is the state of the thing. Now the thing is, there's lots of real-time messages that are popping through, and you can't be constantly hitting the database because the database is slow. It's like if you constantly pull it for new messages to figure out what's changed, then you're going to be hitting the database with a ton of app servers, and that just is going to make it go down. So what people do instead, because you need good response time, good latency, they'll use something like a message queue. You may be familiar with services like RabbitMQ or ZeroMQ. Things are basically you can push those events into the message queue and then get them within all of your app servers. The problem is that's really complicated because now you've added levels of complexity to your architecture. Now this state is trapped between the message queue and the database cluster. It's split in multiple places. So instead you end up with these tiered architectures that are crazy hard to build and keep track of. And this is the reason why people basically have a hard time building these. If you don't have an engineering team that's as big as like Facebook or Google's, or if you don't have one that's like has the know-how to build something like Quora did. If you guys know Quora does real-time answers while you're updating. To build that, they did a great presentation. I highly recommend you look up if you're interested in how this was done before all this was available, even before tools like Angular were available, things like that. Their CTO did a great tech presentation that you can find on how they built their real-time architecture. And take it from him, it's really hard. Part of the problem, as I mentioned, is that pulling data to keep track of updates is cumbersome. You're going to keep hitting the database. You have to constantly figure out what's changed, and that's happening across all the different app servers. Adding new real-time functionality continues to get harder because you got to think to yourself, okay, now I want to build a new dashboard. How much harder does my architecture have to get? How much more complex does it have to get? So it stops you from building new features because you have to figure out how much more state do I need to keep track of. And if you've ever built one of these, I'm going to describe this briefly, but this is probably one of the more complex issues. if you have a real-time message, let's say a chat message comes in, you have a channel that you subscribe to, right? How do you figure out which servers need to receive that message? Should the database tell you? Should the message queue tell you? Should an app server decide? Wow, so you need to decide how. So you'd have to figure out who's the controller for all this. Do I send it to everybody, just broadcast it, or do I figure out how to route them to specific app servers? So you can see how basically this kind of complexity, these architectures, stem from a problem, which is that your database, which should have the source of truth, actually has shared responsibilities with a whole bunch of different architectures and services. So I've described what real-time apps are. So I'm going to first say what RethinkDB is. As I mentioned, it's an open source database that's built for real-time apps. It's really architected around solving this particular problem I just mentioned. I'm going to show you how in a minute. The second is it's a NoSQL database that stores schemaless JSON documents. So NoSQL is a really weird word because it means everything from graphs to key value stores to documents and anything else that basically isn't SQL. It's like horseless carriage. It's the absence of a technology, the presence of one. So when I say NoSQL, I mean we're a document store. You have JSON that you put into the database, and then it pushes JSON straight to you. And the third is that it's a distributed database, and we designed it to be easy to scale. I'm not going to get into those parts. Actually, my coworker Jorge is going to do a workshop. It's about an hour. There he is, right there. About an hour and a half, 2 hours, I think, to dive into how to use RethinkDB, how to write some queries, how to even shard and replicate. And the idea is that we have a web UI and an admin API, which you can shard and replicate with a couple clicks. But I'm not going to get into that today because I'm going to focus on one thing, which is the real-time apps. So I mentioned that it's built for real-time apps. And what that means really is that RethinkDB lets you subscribe to change notifications on a particular database query. Now let's break that down for a minute. Here we have a table. It's the table users within the RethinkDB namespace. And I'm writing this in JavaScript. So this applies to any other language, but this is a basic query. And we have the table users, and then we say .changes. And what that does, when you say .changes, it's going to open a real-time stream, and you're going to get a little ping whenever a document is modified, added, or removed. And that means that rather than pulling the database table and figuring out, OK, tell me what new documents have arrived constantly, instead you just hit it once. It tells you maybe once every 4 hours or 24 hours. You have a push-driven architecture where changes are being delivered to you rapidly. This means no more polling. The database will push changes to your app with a live stream of updates. You have a question?
Is this sockets managing this, or are you using a WebRTS type architecture where you have peer-to-peer?
Yeah, that's a really good question. So when you're talking about sockets and WebRTC and things like that, that's on the app server to client side.
Right.
So that's basically when you have your node server talking to, let's say, your Angular or React front ends. You'd use something like Socket.io, React, or WebRTC, or any one of other web technologies. There's a bunch of new ones for streams which are really exciting. This is tackling the part behind it, which you still would have to do polling traditionally, the database to the app. And on that level, you basically can have your database push changes all the way from the database all the way to your front end.
So your database basically has the concept of promises built into it.
Yes, it's something like promises, exactly. Except, yeah, it's a lot like promises if you think about it that way. Whereas built for these asynchronous architectures where you want to push JSON straight to you and have it deliver all the way to the front end.
Except the promise finishes, right?
Where this won't. It'll continue to hold onto it and it'll open continuously. You can close the change feed at some point. But basically, each app will open a change feed, and this helps you build scalable real-time apps. Because you can just add as many as you want. A change feed is as cheap as a connection, and you're able to build these awesome architectures. Yeah, sorry, quick question, then we're going to tackle this.
Really quick, does that JavaScript snippet that you showed us
Yeah.
about the change sets, do those come down with a particular protocol, like with JavaScript library?
Good question. We're going to tackle a query in 1 minute, and we'll dive into exactly how that works. Okay, so this is what I described basically, where you have your cluster, and they're connecting to the web app servers. This is your node servers basically, or Python or Ruby, whatever server you have. And each server subscribes to RethinkDB change feed, and these servers are stateless. They don't have to know anything about each other. They don't have to communicate in any way. There's no queue that's required. They just open their change feed, say, here's the data that I want to know about, and the server will push updates to it continuously. So what this lets you do is, the question is like, OK, what does it mean to be a real-time app? Or what kind of app can I really build with this? And you'll notice, by the way, that we have this little fellow here throughout the whole presentation. He's the thinker from RethinkDB. And he just does, he'll help guide through the presentation with different things. But the kinds of things that you can build with change feeds are collaborative web and mobile apps. So you have, let's say, a real-time text editor. You want people talking to each other. A multiplayer games where you have player actions that are happening, and you have a lot of events that you need to keep track of. If you want to be able to, you can stream those events instead of having to poll and figure out what's changed. If you have an analytics app like a dashboard, or you want to figure out like thresholds and say, tell me only when this new email ad that I just sent out got more than, let's say, 10% clicks, because now I really need to pay attention, something's really exciting is happening here. If you have a real-time marketplace like an ad exchange, or if you want to do like real-time bidding, you can figure out like, when particular items are getting particularly hot or popular. And the one that's personally to me most exciting, because all this is in software, is connected devices, because this is what you can do with it. You can have a bunch of, for example, sensors living across acres of farms, hundreds of sensors, and they'll just push their updates. They'll just send new data to the cluster. And then let's say that you find out that there's a particular amount of rainfall. It'll ping another app and say, by the way, we have an unusual amount of rainfall now. It's time to go fertilize the crops. Or you can have a bunch of sensors that say, ping me whenever the drone that I'm flying flies over the sensor and it's near my location. So you can see when you have like, fitness trackers, you have anything with real-time streams of data, things are happening in the real world. That's like, you can do all sorts of amazing things with, what they call the Internet of Things, which now actually is starting to become a really exciting reality. So you asked a question about how we're supposed to actually like talk to the database. So we're going to take a little detour for just 2 minutes because we have to figure out how to query RethinkDB. So this is a basic RethinkDB query. We, by default, have drivers available for Python, JavaScript, and Ruby, but we also support, because the community has built over 20-plus driver languages for languages as esoteric and as amazing and fun as Erlang, Haskell, Go, things that are really awesome. So what I'm writing here will be JavaScript, and the thing to notice is that you're not, like in other systems, let's say in SQL, you're going to write a SQL string. If you're using MongoDB, you're going to send an object, which represents the transformation you want to make on your database. In RethinkDB, we actually do a little bit of magic to embed it into your native language. So using native data structures, and you're using debugging tools you're familiar with. And what we do, and this is the interesting part, is that we take the query that you write in, like, let's say, native JavaScript, and then we compile it down. We take the abstract syntax tree, compile it down to expression, send it out to the cluster, and then it gets executed in a distributed fashion, which means that you know that when you do a map or a filter, it looks like you're writing it on your client side, but it's executing on the server in an efficient distributed fashion. So let's take this query one step at a time. What we're doing here is we're going to count the unique last names with what we call ReQL, the RethinkDB query language. We have a users table. So we're going to first we're going to access the table. In the R namespace, there's just like a module to be able to import a library in JavaScript or in Python or Ruby. We're going to access it using r.tableUsers. Then we're going to isolate one of the document properties in our JSON document. We're going to use pluck for that. It's going to say pluck out all the last name fields. Then we're going to take all the set of last names we got, and we're going to say, now get me only the distinct set by calling .distinct. You notice that we're doing chaining. If you're familiar with jQuery or anything else that uses chaining, data flows from left to right. And then finally, we do a count. And the count is saying, OK, we found the distinct set. Tell me how many there are. And so that's basically a ReQL. ReQL embeds natively in your programming language. It feels like native code, but it's actually running on the server. You chain out queries. They're executed and distributed on the server in an efficient fashion, and we support a ton of languages. So if you love, for example, languages that looks particularly beautiful and are anything functional in particular, you'll notice that ReQL is actually we snuck in a little bit of features like functional features. So you could do things like queries, like terms, like for example, a filter can take a function, and you can run that function, could do more complex things like go out to another table and do cross-table joins or things like that. Go ahead.
How do I embed something like an authentication process or just user identification into that?
That's a really good question. So authentication is something that would live past the database. So we expect RethinkDB to run behind a firewall.
Okay.
Yeah.
So in theory, there's no way for me to say, once I hand this object off, it's pretty much open season on the data.
Yeah, it's open season on the data. Now we might add user accounts or sort of views or things in the future. There's been a lot of proposals around that. But right now, we haven't tried to do security to date because if you do security, you got to do it well. And we don't want to make a half-hearted attempt. So instead, we expect you to run it behind a firewall, open a secure tunnel to the database, and then you're able to access it and query it normally. Then your app server will be the one that will decide who's going to get what. Does that make sense? Cool. Yeah.
What are you doing under the hood to service that query, right?
When you say service the query, do you mean to be able to make the query run to the server, or what's happening on the server?
What's happening on the server?
Okay, so that's actually that's the interesting question. Yeah. So it's a distributed system, right? The thing is, we built RethinkDB, and this is why we can do, for example, Changefeeds, which is like it's kind of like it seems simple on the front end, but it's really hard to do on the back end. The reason is that we built it to be extremely parallel and distributed. So originally built RethinkDB to run on solid state. Solid state is a fundamentally parallel storage device. We also built it to run on multi-core. Multi-core you can divide, has lots of cores. You can distribute the load across the cores. So each server has a bit of data, and then it stores that data. It says, okay, I'm going to split this data set across all the different cores and I'm going to split it across the disk in some way as well. And then when a query comes in, it says, okay, I'm going to send it out to all the nodes in the cluster that seem to have the data that's responsible for this. Each node then says, I'm going to send it out to all the cores that seem to have the data responsible for this. And then it runs its tiny computation, and then they bubble up all the way through the cluster. And that's how you have a distributed query happen.
So you're not indexing.
There are indexes. You can have indexes, absolutely. There's secondary indexes, and you can do more complex things. But at its basic operation, like if you're going to do something that's basically, just like without any index, you're just going to say find everything in the cluster. That's how it's going to happen. When you have an index, then there's a little bit more magic, obviously. Does that make sense?
Yeah.
Okay, cool. Any other questions before I go on? Yeah.
How do you handle the reliability of the event being delivered?
Great question. So the question was about how do you guarantee reliability in an event system without a queue, basically. So in its current state, Changefeeds are new. We shipped RethinkDB 2.0, which is the first production-ready release, about maybe a month or two ago. And thank you, yeah. And it was like 5 years of work and about, I think, something like over, I want to say over several thousand issues on GitHub, basically, churned through. And 20,000 commits, I think, on the order of. So basically, when you have a change feed, right now in its current state, when the change feed drops, you won't be notified about anything that you missed. We're shipping shortly persistent change feeds, which means that you're able to replay it from the beginning. You'll say, OK, I disconnected. Now send me back everything from the beginning or as of this timestamp. And then we're also experimenting with having a new version of change feeds in the future where you'll be able to name a change feed and then pass around instead of the query, you'll be able to pass the name around. It's kind of like a channel that you would have in other systems. Does that answer your question well?
Yeah.
Great. By the way, guys, I know I speak really quickly. I'm totally aware of this. So if anything's like, going too quickly or you have any questions, just like raise your hand at any point. I'm happy to answer. So ReQL is pretty powerful. I'm not going to go into all of it right now because it's like a lot. But just to point out a couple things, you could do things like Hadoop-style MapReduce. You can do branching and logic. It's basically masquerading. It's a programming language masquerading as a query language. And all of these things run on the server. Yes?
Do you have an optimized kind of a tool that helps you know if a query that you're constructing is like horrendously inefficient?
That's a good question. So we have a query profiler that's sort of like an experimental thing that we provide developers. I wouldn't say it's the best thing to use. Because it's not very smart about how it solves things. What we're adding soon, because right now the easiest way, because you're chaining things out, is to sort of take each part of the query, run it, and see how fast it is. And we're going to be adding, we're playing with some ideas on how to do a really clever optimizer, where you can either, what we're thinking is maybe you would insert the optimizer into the middle of the query and say, take this part of the query, begin optimization, end optimization. And that way, for some things like filtering or things you can do, like it'll know how to do a filter quickly because it'll just index it on that property, for example. Does that make sense?
Yeah.
Cool. All right, so we're going to keep going. Just a couple things, more things you can do with ReQL. It's a pretty full-featured database in general. You can do geospatial. You can even store binary data like images and PDFs. You can even, and this is a crazy feature, but it helps bootstrap your initial data set. You could do things like go fetch a document, like a JSON document from an HTTP, via HTTP from a URL and pull it into the database straight up. So that's really great if you're just playing around and want to demo it. And start to play with some JSON data. But here's the magic. So we talked about the query language. Here's the magical part. Change feeds work on queries, not just on tables. So we're going to take another query that we have. And here we have a user profile and a social network. We do r.table user profiles. We filter it. You notice that the filter is accepting, you can send it just a JSON object, which is, we'll just say, get this key for me. This is a little more complex. It's saying, for each document or row in my table, look up the likes property and tell me if it's greater than 30. So we're getting notified. We're first asking with this query, what user profiles have over 30 likes? And then when we tack .changes on, suddenly now we're notified. We'll be sent a ping whenever a user profile gets particularly popular. So the magic of this is that basically clients can subscribe to a real-time stream of updates on queries. And this is really exciting. So I'm going to show you an actual example now, because we love examples. And so what I built is, I built a little tiny app, and I did this really quickly, so I apologize for the CSS and things like that. But I hosted it at questions.rethinkdb.com. So I want any of you guys on computers and such, go there right now. I'm going to pull it up right here, and let's just see if we can see this. So type in your question about RethinkDB. You can ask me too, of course, but I'm going to just ask, who is the thinker? OK, so now if you guys see questions that you like, upvote them. And what I'm going to show you is, there we go. Wow, we're really getting a lot of upvotes. OK, so let's put a couple more in here. Who is Jorge? Jorge is sitting right there. OK. All right, so we got a couple questions now. Now I'm going to show you. Let's just hold off on the updates for just a moment, because I want you guys to press it when I tell you to press it, because we're going to look at something really cool. All right, so we're going to open the RethinkDB admin console. Now, this is what it looks like. Wow, we can see that writes are happening right now as we're talking. So makes sense, right? So basically, this is a dashboard that we have. It allows you to do both to monitor and to administer the cluster. So you'll notice that there's a couple. Looks like some people are trying to mess with it here. So we can go and look at, for example, the set of tables. You can go to the questions table, and you'll notice that we can see the writes happening, and we can do some sharding replication. I'm not going to touch that at all right now. You can go to Jorge's talk, and you can learn about all of that, because it's super fun. I'm going to go to the Data Explorer. The Data Explorer basically lets you write queries. So we're going to first just find the set of, I'm going to bump this up so we can all read the queries I'm writing here. So I'm going to go ahead and list the questions in our table. And you'll see that we have these questions. They all have an ID that's a primary key that's been auto-assigned by the server, and it has a set of points, and you can see all the questions that have been asked. Now, if I run it again, you'll see that it's changed. But what we really want to do is we want to use Changefeeds. And just say .changes. And now we have a real-time stream. And you'll see it's flashing whenever we have a new update coming in. Now you notice, let's examine this for a second, because the output is interesting. It tells you exactly how to use this. You guys are really going nuts on this. So well done. OK, so we have new val and old val. Old val is what it was in the database prior. New val is what we're inserting into the database now, or what's changed. If old val is null, it means the document didn't exist before. That means it's a new question. Can we all stop for 1 second? 1 second. Hold up, guys. Hold up. All right. I want one person to insert one person. Can you insert a question? Just one.
I did the one about Firebase, but let's see.
Just a new one. So we want to see what a new value looks like. Great. OK, so here we have old val is null, and the new value is his question. How old am I? The answer is I'm 27. That's great. No, it's perfect. I love it. There we go. Perfect. OK, so if new val is null, that means we've deleted it. So I'm going to say, let's take this question. Let's take a question. I'm going to take this question. Mike is awesome. 1 second. I'm going to pause the change feed, actually, because we want to just examine this. All right, so let's take Mike is awesome. Where is it? So we have so many updates coming, I can't even tell where they are. OK, so we're going to do this instead. We're going to take who is the thinker. And I'm going to say, I really don't like this question. I don't want to answer it. Now, I asked the question, so it's a little ironic. But I'm going to go ahead and say .get, and then say .delete. Now let's look here. Who is the thinker? And when I hit delete, you can see that question just goes away. And so what the update that would come in would be new val will be null. And then if you have just properties that have changed, you can compare old val and new val to tell what's changed. Let's go back to our change feed, because that's super fun. But you know what? I really don't like all the changes that we're getting, because it's a ton. So we're going to do something more different. We're going to say order by. And we're going to say, I've set up an index prior to this, which is indexing on the points property, meaning the number of points. OK. So I'm going to say, and then I'm going to say limit it to the top 3, because that's all I really want to know about. I'm going to say .changes. OK. So now I'm getting only the updates for the, well, actually, see, notice what I did here. I did order by points, and I got the lowest points. What I want to do is I want to do right, so we want to say on index, sorry, I'm missing the syntax here, r.descending on the points. So what we're doing now is we're going to say, there we go. Now we got the highest ones. Notice what I did there is I just put a little ReQL expression to flip the order. And now it's saying on this points property, instead get me the highest. So now we're only going to be seeing the top 3. You guys got to 1,100 points. Well done. This is like the cow clicker game, but it's like way more fun for me. So now it's only pushing me the updates on those top 3 questions. And that's really cool, because you notice what I did there is I actually just wrote a query, and then I just said, you know what, I really want to just filter it. And now we're doing .changes. Now I'm going to show you one more thing. Because as you know, you guys are all seeing the updates yourself. I built a little dashboard to show the updates that are happening. Now, it might get a little crazy because you guys put a ton of values here. But I'm going to just pull it up.
You could only let each person vote on each question once.
That would definitely help, yeah. Next time for my talk. All right, so now we have a graph of the most popular questions. And you'll notice that, let's take the top question. What is my favorite color? I'm going to answer that question. Yes. All right. So we're gonna just do, let's see, get.
Are you running this locally from your machine?
I'm running this actually on a server, so guys, please don't mess with me. I didn't put any security because I just threw it up for the talk. I would really appreciate it if you didn't mess with me. What is your favorite color? So I'm going to filter for this. Okay. So now I have this question. I'm going to grab the ID for this. Oh, actually, you know what I'm just going to do? I'm just going to delete it right from here. Sorry, man. I'm going to answer and then delete it. 1 second. I think you guys are pushing so many updates. My web browser is slowing down. All right, here we go. Okay. So I'm going to delete this, and we're going to go look here in this dashboard. And you see it's moving. When I delete one of them, well, I think my browser was covering it, but the point is that it deleted the column for it. And this dashboard is basically what it's doing is it has its own change feed, saying, I just want to see all the questions, but just the points. And now I just want to see how they're adjusting over time. And the best part is that these two apps know literally nothing about each other. The only thing that's connecting them, there's no queue, there's no nothing. The only thing connecting them is the database. Because the database is the source of truth, and it can push updates to both of these apps. So I'm going to jump back to my presentation. We can dive back in for a second. Go ahead.
So those UIDs that you're using as a primary key or the index for each
Yeah.
entry, if I wanted to restore some of that data, I'd have to know what that key is, correct?
If you want to restore the data, when you say restore, what do you mean?
So, for example, when you hit delete or when you use the delete
Yeah, the function, yeah.
function, it's basically wiping that out. If I wanted to restore the data and all of its history, I would have to have that ID.
You'd have to have it stored somewhere else because this is the source of truth. When you say delete, it's gone from the source of truth. It's no longer
So it
in
deletes
the...
all change logs on it as well?
Yes, a stream is, there's no history of change logs that you can connect to and sort of see what's it like throughout history. It doesn't store revisions, at least in its current iteration. That we could add that at some point, but we haven't done that yet. You could store the revisions in another table. You could open a change feed and then start inserting all the changes into a table.
Right, but it doesn't intrinsically do that.
No, it's not. But you could easily do that. It's pretty easy just to connect it. We designed ReQL to be very composable, so you can sort of fit all the pieces together, and we try to build things on top of each other. Go ahead.
What algorithm are you using for resolving multiple updates to the same database document?
For resolving multiple updates to the same database document.
Yeah.
Do you mean if two people try to write to the document? So this basically, it's whoever gets the write first is the one that's going to get it in. There are no transactions there's no asset in the database. There's no way to sort of guarantee that one, like if there's a competing write. Go ahead.
So is there only one, there's only one place for that data in the document? You don't have it distributed anywhere?
No, you say there's only one place. So yeah, so basically this is a immediately consistent database. So when you write it to disk, it's like written, and that's the new version of truth. Now if the other person gets the write in after it, then it's going to be the new version. Exactly, it's going to clobber it.
There's not a duplicate copy in there?
No, there's no way to, I mean, you could write your query in a way that if you find out that it's already been inserted, you just add it into a new one.
On a different,
No.
okay, so if you lose a server, you lose the data.
Oh, I see. Oh, you mean replicate? Do you mean replication?
Yeah.
Okay, sorry, I misunderstood your question. Yeah, so the database has replication built in and sharding. So basically, I can show you that in a minute if you're curious. But you can define replicas to be like, I want to shard this data set, and then I want to have like multiple replicas of each shard. And you can say, I only want these replicas to live on this server, and then on that server. You can tag servers.
Replicas are master slave.
They're master slave, exactly. Yeah. We decided to favor consistency over availability for this because it fit the use case much better. If you want availability, other databases like Cassandra or React are like much better databases for this. Okay, so let's continue. Are there any other questions actually before I move on?
Then just last comment about availability.
Yeah.
Are you saying that, like, if a server goes down?
Let's talk about what happens when a server goes down. Yeah, that's a good question. Okay, so right now, in its current state, when a server goes down, a couple things will happen. So there is no automatic failover currently. It's coming imminently. We've been working on it for a long time. We did not add it because for a while because when we build things, we try to do it right and not like we take our time with it. So we've been building failover, automatic failover for a while. In its current state, if we kill a server in a cluster, you'll get a little issue will pop in the web UI and in the API that you can use to access to understand what's happening in the cluster. And it'll say a server is down, a master is down. If it's a secondary, it doesn't really matter because as long as you've said, you can specify I want a minimum of 3 replicas, and if you have more than 3 and someone dies, it doesn't really matter. But if you go under, it says okay, we no longer can satisfy the requirements or master has gone down. Now you have to go in the web UI or in the API and you have to manually press a button to say now switch over to a different master. The reason we did that is because that's predictable. Now what we're adding is Raft. I don't know if you guys know what Raft is. Raft is a consensus protocol for basically determining who gets reelected first. There's a bunch of them out there. Raft is the easiest to understand by people. It's easy to understand. And we have an implementation we'll be working on. Actually, you can check it out on GitHub right now. It's in a Raft branch. And it's been worked on for a while. So when we have Raft, it'll be soon. Everything will just fail over automatically, and you won't have to worry about it at 3 a.m. Does that make sense? Cool. Any other questions? Okay, cool. Let's get back to this. Here we go. There's my phone. Sorry, guys. I'm using my phone to control the presentation here, so just give me 1 second.
I do have one other question, and answer this whenever you
Yeah.
want or after. Or whatever,
Sure.
But we're using Firebase right now, but I'm really interested in RethinkDB.
Yeah.
And I'd love it if you could help us understand what things you guys do better according to your.
Let's tackle that actually right now because it's actually really interesting. So there's a bunch of really cool real-time services out there. Things like Pusher, Firebase, PubNub. I'm missing a couple. What's that? Parse, exactly. Now, all of these basically do just simple events. So you can do like inserts and gets. Firebase has like Mongo running under the hood, I think, in their implementation. And the thing is that they basically, but first of all, it's a service. This is self-hosted. You can just own your own data and it's on your own service. Yeah. But also, the kind of queries you can run are usually restricted to a limited set because it's something that they can easily deliver. In this case, every query that we have in the system, we only added queries to the query language if they could be clustered, meaning if they could be distributed. So every query is efficient and distributed, and this has a much wider scope of queries you can run. It also lets you do more granular changes on Changefeeds because you can either specify it with filters, or you can do things like, in future versions we'll have like the persistent Changefeeds with all sorts of other features. So it's more of a building block for real-time architectures than a service that you plug in to be able to shuttle messages or events. Firebase is great when you're getting up and running with an app, but it's for a very different use case. Does that make sense?
So yeah, it does. But when you say getting up and running, so is there less administrative tools for could I just launch? I know there's hosted RethinkDB already. Could I just launch one of those?
Yeah.
And log into the control panel?
Absolutely.
The same things that I do in Firebase.
Pretty much. The thing is, Firebase gives you like a login with like usernames and passwords, and they have a web service that's always running that has like the administration tools built into that with like metering and billing and things like that. With this, it's pretty simple. So Compose.io, if you guys know Compose, used to be called MongoHQ. They actually run multiple databases. They were the first hosted service for RethinkDB. We're very close to those guys. And they run like Redis, Elasticsearch, a bunch of other ones. It's really easy to get RethinkDB 2.0 on Compose. So you can just launch an instance. We have Amazon machine images available. There's Docker instances that's in the official Docker repo, so you could just like spin up and running. And all you have to do is just you pop over the administration console and you're off. That's pretty much it. It doesn't have, it's not a traditional web service, right? But because it has the UI and you can run it through a service, it's pretty much the same thing. Does that make sense? Yeah. Cool. Any other questions, or I'm going to move on here? Okay, great. So as I said, if you want to check this out yourself, I'm going to post the deck later, but I have a repo that I posted. My name is long, Russian, and hard to spell. So, if you could just find me on Twitter as well, because I'm connected to RethinkDB. I'll post this later if you guys want to check out the code. I threw it together really quickly, but it should give you a good sense. We also have a ton of Changefeed demos on RethinkDB's site to get started as well. So examining one more time, just the architecture we have here. We had 2 question servers. We could, you guys are running a questions app, and I was myself. We could have multiple of these servers running side by side. We had a different server for the dashboard. They know nothing about each other, completely stateless. And what they do is they open Changefeeds to the cluster, which is the one source of truth. And changes are pushed to each stateless app server. So I talked about some problems about how it's hard to build real-time architectures. And let's go over what RethinkDB does to make that better. So for one, polling for data is slow, cumbersome, hard to maintain, right?
Amen.
There we go. Good man. So push access model, it simplifies real-time architectures. It makes it so that you have push throughout the entire thing from start to finish. One source of truth makes it really easy to manage state. Your database should know everything about your data. It should be the place where all the computations happen. And it should deliver the updates when it knows that something's changed. And RethinkDB is that first database for the real-time web. CouchDB is the only other database that I know of that does a good job with some sort of syncing. But CouchDB is really interesting because they designed it it's a really amazing thing they built actually, because they designed it for a world where they envisioned that network connectivity would be spotty. So their whole thing was, I want to download a copy of the data to mobile apps or to servers that are running in different parts of the world. When the network goes out, we want to, and it comes back up, we want to resync those data sets. We built for something very different. When you have a real-time app and you want to figure out specific questions and you want to be notified when it changes, then you get pushed these updates. So we are the first database I know of that does this. So if you want to learn more about RethinkDB, you can get started on rethinkdb.com. There's an easy install page to get started. It takes it's brew install RethinkDB if you're on OS X, or apt-get install. There's Docker images, as I mentioned. There's services you can get up and running with. The docs are pretty full-featured. And the API page will give you a good sense of what else you could do with ReQL. In general, ReQL is pretty powerful. We actually originally thought that one of the things that was coolest about it is it felt very much like Mathematica for JSON. It was like you can do a lot of really expressive things, pull JSON and play with it, mess with it. But the real-time apps is really where we have our heart and soul is right now. And if you want to follow us on Twitter, RethinkDB, you'll find out the latest news and updates. We have a lot of really cool stuff coming. Biggest features that are coming and are in the works right now, besides Raft for failover, which is really exciting actually. We finally have, it's like maybe the most like +1 issue, is Windows support is coming. We started porting to Windows. Really hard to do because RethinkDB was built in a very deep way, where we actually have like a custom coroutine implementation. There's even some assembly in there. It's like low-level stuff, and so to port it to Windows, it's an effort. But we have it's being worked on right now. Great engineers are working on it, and we also are adding Java support as an official driver. The reason it particularly chose Java is because it'll open us to the whole world of Scala and everything else in the JVM, and so we want to bring real-time stuff to there. We also really excited about .NET because, especially with how Microsoft's making great open source moves. With SignalR, it's a really good fit for that as well. And there's a great community.NET driver that you can use as well. So that's pretty much my presentation. I want to stick around for, we have maybe 5-10 minutes for more questions. In fact, let's go to the questions app. Let's figure out what we actually have to answer here. Yeah, absolutely. It's not documented at all, so I apologize for that. I'll go back and I'll fix it up later. Let me just, here we go. Yeah, Glukhovsky. In Russian, you want to pronounce it in Russian? My name in Russian is Mikhail Zakharovich Glukhovsky, but it's Mike Glukhovsky. So, sound good? Yeah. All right. So let's go back to these questions. Now, it might be a little bit hard to read these because I am apparently terrible at CSS. So let's actually go to the table, and we're just going to pluck the questions. That's because question isn't a field, but question is. All right, how old am I? I'm 27. When or is RethinkDB available in the package manager for Ubuntu without compiling? Available right now. If you're talking about the main repos, we don't do the main repo because we deliver updates. Actually, we have a target of every 6 to 8 weeks to ship a new version of RethinkDB with like major features. Very fast for a database, but it keeps us on our toes. And for that reason, we have our own apt repo. It's pretty easy to get up and running. How does this compare to Couchbase? Couchbase is... So I haven't actually personally used Couchbase, so I'm going to try to refrain from getting into specifics without too much detail. But Couchbase, I mean, it's similar. You can store keys and values in it and documents. They have a query language, but it doesn't really have any of the real-time features. And it's really for different use cases. If you're doing things like simple data storage, gets and sets, if you're doing things like caching, Couchbase is, I think, a pretty good fit for that. And they have a bunch of cool features, but nothing in the real-time category. When is security coming? So we're adding. Is it okay, by the way, that I'm running through like this? If you want to stop me, raise your hand, by all means. When is security coming? So security is something about this so we can all read together. So we avoid doing security, as I said, because we want you to run it behind the firewall. We don't want to give you a half-baked solution. We're going to add a tool to help make it easy to run it behind SSL, so you can have an encrypted cluster pretty quickly to have a front end in front of it. And we're going to push that burden onto another tool like OpenSSL. Are we hiring? We are absolutely hiring. Go to rethinkdb.com, rethinkdb.com/jobs. And we are in particular hiring if you're a systems engineer and you love C and C++ and you want to help build stuff for the real-time web, like come talk to me afterwards. Don't even bother going to, just come talk to me. Who are the guys who came in the room earlier? I don't know who they are. Oh, I know what. There was a bag that was stuck under the table, and I think that there we go, exactly. So someone left their bag here, I think.
I work with them.
Very cool, got it. Thank you for the compliment. How efficient is RethinkDB with server resources? It's pretty efficient. It's way more efficient than it used to be. We've done a lot of optimizations to reduce disk space and CPU usage. What we do is whenever someone, and by the way, if you ever have a problem, GitHub issues, go straight there, open an issue. That's where we live and work, and that's where we do everything. So whenever we see someone have a server resource issue, let's say high CPU usage on a particular query, we then go and ask them and work with them to get a copy of the data. We replicate it on our internal clusters, and we figure out what's happening and optimize it. So we take it on a case-by-case basis. Yeah, Mark, what's up?
Yeah, so you said you don't have the revision history, but do you have a journal? Because if the master goes down and then you're... So it replays, it has a journal, and yeah, exactly. It'll send events out. But it's not for Changefeeds, because that would be on a too granular basis. Just it tracks the current state of truth, basically. Okay, how does licensing work? Okay, great. So it's open source. We are AGPL.
And we did that specifically because we wanted to encourage companies not to make changes and own them. We want to make sure they're part of the community. The drivers are all Apache, so there's no worry about GPL entering your environment. We also we sell commercial services for development support, for production support, for training. If you guys want to get started in your company and you're not sure how ReQL works exactly, we'll come in and help you get started. If you're interested in any of that, just come talk to me afterwards. And as part of that, there's commercial licensing if you really need it. When is the workshop? Jorge, when is the workshop?
Tomorrow at 3.
Tomorrow at 3. Okay. Nice ad. I love that. Ads in RethinkDB. How does RethinkDB persist data? So basically, whenever you write by default, we're in hard durability mode. So whenever you write an insert, it's going to get act to disk, and then it's going to come back with a response. You can use soft durability mode as well, which means it'll batch in RAM. But whenever you do an insert into RethinkDB by default, your write will be on disk. It will be safe. How scalable is RethinkDB? So we internally have run clusters of 16 to 24 nodes that are pretty beefy on large data sets, like in the hundreds of gigabytes to terabytes category. We have reports of customers doing larger ones, but we haven't internally tested it yet. We're going to be releasing a benchmarking and performance report at some point soon, so it'll be something you can say, okay, what can I reasonably expect in my cluster? But it's on par with or better than most other systems in this space. Can you port my SQL database automatically? The community actually built a ton of tools to be able to do that, but we haven't done anything by default. I think we addressed Firebase versus RethinkDB.
There was a question about security up there. Is there?
Yeah.
I assume there's like TLS based or.
Yeah. So as I mentioned, we don't do security built into the product yet. We're going to add a tool to help in front do like TLS or SSL or something, so that if you want to get an encrypted cluster up and running right now. But what we suggest you do instead is, let's say you're running on Amazon, run it behind a firewall, do a private VLAN so you can basically connect all the nodes together really easily, and then you just tunnel into it to be able to write to access it. And there's a ton of tools to help do this. It's been sort of well explored. Compose.io actually built a ton of great tools when they built their hosted service to help make those connections happen.
So but this brings up a point of you need a middleware layer that's going to do the writing. Is that what you're?
You need a middleware layer. So the middleware layer would really be, well, your app would do two things. One is it would import the RethinkDB module, and then when it connects, it would just use like a middleware layer basically to be able to say open an SSH tunnel instead of opening just a generic connection.
I see. So I could still take the approach that we use on Firebase, which is to write directly from the client to the database server.
Yeah. So you can't connect. We should chat about it afterwards because it's a little bit complicated. But like you can do similar things in Firebase with the right architecture, with the right set of tools, basically. Make sense? Okay. Let's keep going here. This is fast. Yeah, I speak really quickly, guys. I know that. Is there anything RethinkDB isn't particularly well suited for? It's not targeted at deep analytics. Don't use it for that. But it will do Hadoop-style MapReduce, and you can do actually a ton of analytics queries on it that are pretty effective. But if you really need to crunch like large batch jobs, use a better database that's suited for that. It's also, you can do search if you really need to, but don't do that. Use Elasticsearch. We actually built a great plugin that will pull in your data. It'll periodically suck data from RethinkDB into Elasticsearch. So it's using Logstash plugins. So if you want to do them side by side, you'll be able to use them. Can I have clusters? Absolutely. It's really easy. You do RethinkDB -- join, and you specify the IP address and port of the other server. Yeah?
Is it possible to get RethinkDB to spit out a quasi-schema of some sort that I can use to map to an SQL service so I can use that for more analytics type data? Or
so when you say schema, you mean we have these keys and what types there are, or just we have these keys?
You have these keys and they're organized or they're relationally solvent in some respect.
Oh, saying how they're connected. So we don't have anything that defines relations by default. There's middleware people have written to do that really well. I think that would be really cool to create, though. Like, that's a really cool idea. We're going to add optional schema validation for things where you might want to know, like, hey, my document really needs to have like a user field or something like that. But right now, in ReQL, you can do a lot of things. Like, you could say, here's my document.keys, and I'll tell you the keys that are there. And you can go and like do some more logic. So you can really build it yourself. But I think that people might have built some stuff already in the ecosystem. Go ahead.
I can send you a query that will try to infer the schema.
Jason actually has been running RethinkDB for a while, and he built a couple of libraries that are in the ecosystem, including an ODM called Reheat, and he's building a admin UI called ReQL Pro, and a whole bunch of projects that are really cool. An adapter for JS Data, if you know JS Data, which is for writing isomorphic queries on the client and server. And so you can come talk to it afterwards as well. I think it might have some answers. If you're okay with that, Jason, sorry. Yeah.
I'm just curious.
Yeah, sure.
Hey guys, the workshop is at 1:30 tomorrow. I'll be doing it. We'll like go through installing it. But I said 3 and it's actually 1:30.
Okay, there we go,
You know,
1:30.
Right here in this very room. You should all come.
All right, question, yeah.
So how does it handle time series data, and how does it compare to InfluxDB?
Influx is really great for time series data. You can do date times here. Has like a lot of complex support for doing date time support. It would depend upon the use case you have. I would say this can do most things in time series, but it's missing some functions that I would really like to see to help make time series even better. So like there's specialized functions that you can do for like, so in every category, let's say geospatial, we have a pretty full featured set for things like get me all the points within this distance or like within this area. And we don't have as much yet for time series, but there's a bunch of proposals on GitHub, and you should add one if you think of one that you really like to see. Cool. Yeah.
Like consistency, transactions.
Okay, so we have single document. On a single document, you can ensure that you don't have writes that happen. Everything that gets into the database is immediately consistent by default. You can turn that off if you want. It is not ACID, however. If you want ACID, there are other databases that are probably better fit for this. Make sense? Cool.
So this may be related to my last question, but it sounded from what you were saying that there is not the concept of like security rules like Firebase has.
Yes.
Where you can confine the manipulation of the data into certain ways, right?
So what you really want, if I understand correctly, is you want to define a token and say this token is only allowed to make these manipulations. That would be the ideal approach.
Sort of. Like, I'm thinking more along the lines of that I can define the ways that people should interact with my data in a more complex way than merely tokens. Like I can say, I only want you to be able to increment this field by 1 every time you do it, or something like that.
So that would be really cool, and we don't have that yet. There is a feature on GitHub, I think titled User Accounts, which is somewhat similar to this. We've been exploring different ideas on how to do specificity on a particular client or user to be able to say, you have permissions to make these changes, but not these changes.
Yeah, or to look in the database itself to see if someone has authorization to look at something else.
Yeah, exactly. No, that would be amazing. I'd like to talk to you about it afterwards, actually, and we can maybe spec it out. Yeah. Mark?
Minimum nodes in a cluster or not allowed number of nodes?
There is no minimum number of nodes. I recommend you run 3 at a minimum because you want, replication and you want 1 in case something fails over.
So if you have an even number of nodes, what happens when you split down the middle?
That's a good question. So I'll give you guys, honestly, I'm not a distributed systems guy by background. So if you have a question about that, we can go ahead and talk to the engineers and we'll find the right answer. Anyone else?
Знаешь, как говорить по-русски?
Говорю по-русски, да. Очень хорошо, очень приятно. Yeah. Okay, that was good. I'm very impressed. Okay, do you know Russian or do you?
Чуть-чуть учился там 2 года.
Очень хорошо, that's great. All right, so I think we're out of time, guys. It's just past quarter of. So if you have any more questions, come find me. If you want to find out more, these little cards will help you get started, and we have some t-shirts and stickers still left. But I want to thank you all for coming. This is my first time in Utah, and it's amazing. I'm seeing every day the mountains. I'm like in awe, and the people are even nicer. So it's like I'm having a really great time. So thanks so much, and thanks for coming.